Thing on our list is to look at what's called rectangular hyperbolas. Sometimes we call them equilateral hyperbolas, depending what book or teacher you're talking to. And the equation is completely different from anything we've seen in hyperbolas before. It's x times y equals k. And there's a condition here. K cannot be a negative number. A zero. Sorry, brain dead. K cannot be 0. It's got to be a positive number or a negative number. It cannot be 0. And if I can get you to think back for a moment, you have seen equations like this before. Remember inverse variation? In your mind, solve this equation for y. You would divide both sides by x. And you get y equals k divided by x. Y equals k divided by x was y is inversely proportional to x. So this is what happens when we graph an inverse proportion. We still get parabolas, but they're a little different. So what we want to do is, first thing, we want to look at this number k and decide if it's positive or negative. If it's positive, when we graph it, my hyperbola shapes are going to be in quadrant 1 and quadrant 3. For both of these rectangular hyperbolas, the center is always 0, 0 for the ones we're looking at. The asymptotes, the lines that you draw so that you can draw your hyperbolas closer and closer to the asymptotes, never cross, never touch, never get parallel, they're always the x and the y axis. And we had two axes of symmetry. If k is positive, then the transverse axis of symmetry is the equation y equals x. Remember, transverse axis of symmetry is the one that goes to the vertices. The conjugate axis of symmetry is y is the opposite of x. And if anybody asked you about the domain, remember what x values work, what x values don't. The domain of all rectangular hyperbolas is every real number except x cannot equal 0. Can't happen. And we're not going to ask for the foci, but we are going to ask the graph, and we're going to ask for the center, and we're going to ask for the vertices. Here's how you calculate the vertices if k is a positive number. Here's what you do. Your first vertex is the square root of the absolute value of k, the square root of the absolute value of k. Your second vertex is the opposite of the square root of the absolute value of k, and the opposite of the square root of the absolute value of k. So here's what the graph looks like. You've got the center at 0, 0 always. The x-axis and the y-axis are the asymptotes. And you're going to actually plot this. We'll show you that in just a moment. Right now I'm just trying to explain the formulas. But if k is positive, one branch of the hyperbola is in quadrant 1. The other branch of the hyperbola is in quadrant 3. The axis of symmetry that goes through the vertices and the center is called the transverse axis of symmetry. The other one is called the conjugate axis of symmetry. It does not actually intersect the hyperbola, and that's the same when we talked about regular hyperbolas as well. And then there's only two vertices, and to calculate them, just remember, in quadrant 1, you've got to go positive, positive. And so it's the square root of the absolute value of k, square root of the absolute value of k. In quadrant 3, to get this point, you got to go negative, negative. So the opposite of the square root of the absolute value of k, and the opposite of the square root of the absolute value of k. All right, in the other situation, if k represents a negative number, there are a few differences. The first difference is that the two branches of my hyperbolas are in quadrants 2 and 4, not quadrants 1 and 3. But the center is still going to be 0, 0. And the asymptotes are still going to be the x-axis and the y-axis. However, the transverse axis of symmetry and the conjugate axis of symmetry switch places. The transverse axis is now y equals the opposite of x, and the conjugate axis is now y equals x. The domain is still the set of all real numbers except x cannot equal 0. And the vertices, here's how you would calculate them. The opposite of the square root of the absolute value of k, and the square root of the absolute value of k. That's one vertex. And then positive, the square root of the absolute value of k. The opposite, the square root of the absolute value of k, is the other vertex. So to look at the picture, we are now in quadrants 2 for one branch and quadrant 4 for the other branch. Center is still at 0, 0. My transverse axis of symmetry goes through the vertices in the center. My conjugate axis of symmetry is perpendicular to that going through the center. Those two lines of the axis of symmetry we can fold it on. And you can reason out where the vertices are if it's in quadrant 2 and quadrant 4. Quadrant 2, we got to go left, which is a negative x value. So it's the opposite of the square root of the absolute value of k to go left. Now we've got to go up, which is positive the square root of the absolute value of k. In quadrant 4, x has to be positive, so it's positive the square root of the absolute value of k. Y, we go down, has to be negative, so it's the opposite of the square root of the absolute value of k. And that's explaining the formulas. We'll do a few numerical examples momentarily.